Cool. So we'll have kind of two classes of presentations, the open class and the ones that are within the theme of the hackathon, which is quality. Go ahead and use the spreadsheet to add your name and your project to the list. And Paul, I know you need to go soon, so let's go ahead and get started with that.
So quick update on BRT. So the last time I was talking about BRT, we had one pretty big pending problem: how we can avoid overhead on when we are freeing blocks. So because with BRT we cannot rely on the dedupe bit set in the block pointer, so we actually on every free have to go and check if we don't have to update the BRT table. So I found a solution to that some time ago. I'm just dividing all VDEVs in regions, like 1 gigabyte regions, and I keep a reference counter for every region. So this reference counter for the region is a sum of all BRT counters for every block in this specific region. And I can keep those counters in memory because they take very little memory. It's 8 kilobytes per 1 terabyte of top-level VDEV. So it's very little, so I can keep those in memory. And so then when I have to free the block, I just consult this regions counters. And if it's 0, then there is nothing to do. If it's more than 0, then possibly the given block is in BRT. So then I have to go look up the entry and update the entry. So this pretty much fixes the problem. What I implemented today was just some few cleanups, and the idea Alan had, which is that both deduplication and BRT somehow serve similar purpose. So we could have blocks that are both deduplicated using the mechanism we have now, and also cloned using BRT. So we can have the same block in both tables at once. So Alan's idea was to check the bit, and if we have the duplication bit, then the block is already in the deduplication table, so there is no need to create an entry in BRT table. We can just bump the reference counter in the DDT. So this basically means that using BRT we do manual deduplication. So if the dedupe bit is not set, then we simply go to BRT table and just increase an entry in there. We cannot resign from this table because we also want to clone blocks that don't have dedupe bit set. So we just want those two functionalities to work nicely together. Yeah, one thing I was hoping to resolve today was to make sure that that BRT will work on different architectures, so the byte ordering will work properly. So I started to implement that, and I realized that actually I think most of that is handled automatically by ZAP. So it seems that I don't really have to do anything special, but I will be confirming that on Slack later. So I can show you a quick demo. So let's say we have dedupe turned on the pool, and there are no blocks yet. So I will copy one block. I will copy one block with dedupe on. Yes, let me copy the same block again. Okay, now the dedupe ratio should.
You need to do ZVol sync. Oh, there you go.
Yeah. So Now let's turn off dedupe. And copy the same block again. Okay, so now I have two blocks with the same checksum, but one have dedupe flag set and the other doesn't. So if I clone the block that doesn't have the dedupe flag set, it will be added to BRT table, and BRT ratio should be increased. Yeah, but if I clone the block that has dedupe bit set, then we should just increase the counter in the dedupe table. Yeah. So we are just reusing dedupe table in that case. Yeah, so that's pretty much it. I did some tests yesterday, some initial performance testing. So there is more or less like 2 orders of magnitude difference between copying the file and cloning the file. So that's it. Thank you.
Cool. That's super cool. I'd love to see your progress on this annually, I guess. But it looks like it's getting really close.
Yeah, I think so. Just some few really, I hope, minor details to flesh out, but might turn out to be pretty hard, like compatibility with VDEF removal. So I didn't touch that yet. So we'll see.
Yeah.
Thanks.
Cool. All right. Looks like next we have Paul with rerunning tests.
Hey, so I'm going to go ahead and share my screen because I have a very quick demo. And while the demo is running, I will explain the feature. So everyone can see this okay? All right. So as we talked about a little bit yesterday during the hackathon planning session, the automated PRs that get filed, or the automated test runs that get started when you file a PR against the OpenZFS repository, are a good idea in theory, but in practice, they're basically always red. And the reason is that we have a number of flaky tests and we have a number of issues that crop up from time to time. And one of the things we talked about improving was trying to get those automatic test runs to be more useful. You want those to usually be green check marks so that when they are red X's, it's meaningful and you can actually know that you should go look at something. So to that end, one idea was to automatically rerun all failing tests that get started by those automated runs. So I've added a new flag to the ZFS tests script, the -R flag. And what that stands for is rerun. So what I'm doing here is I'm running a single test suite, the case normalization suite, and it has a few known failures in it. And so you can see, we have a couple tests coming that have failed. And once this initial set finishes, we automatically rerun all the failing tests along with the necessary setup and cleanup steps. And then at the end, you get the results summary and it informs you, hey, these are expected failures. And we didn't have any unexpected failures in this run. This work is partially based off of an Alumos PR. With some slight tweaks to make it a little bit more usable for the automation workflow. And then there's also some changes to the GitHub workers to make them automatically use this flag. And then another change that needs to be made in the buildbot repository to make all the different builds use this flag. But a pull request has been filed for this and it is visible on GitHub. So if people want to take a look at the code, they can. That's it. Thanks.
All right. Then next up we have Trevor and Brian. DRAID rebuilds.
Cool. So my name is Trevor, and at the Los Alamos lab, we've been kind of experimenting with certain NVMe drives, and ZFS rebuild performance. And the drives that we've been kind of using are the PM1725Bs from Samsung. And something that's interesting that we notice is when we sort of emulate a workload, a rebuild workload with ZFS, we emulate one that would be from ZFS on like a single NVMe drive, we see that the read and write bandwidths are kind of divergent. So this graph is emulating an 8:1 read write against a PM1725B. And we kind of see something similar in trying to emulate like a 3-reader and 1-writer case, also on the same drive, where the reads are quite higher than the writes. And these are with the Samsung PM1725Bs, like I said. But something interesting that we see with a different NVMe drive, we see with the some certain Kioxia drives that the read and write bandwidths are pretty close to each other as we vary the percentage of jobs that are writing versus reading. So here with ZFS, will probably be around the 10 to 20% of writing jobs here. But even then, the read and write bandwidths are pretty close to each other. And so we decided to try a regular ZFS rebuild with these drives, but we actually see the same thing that we saw with the Samsung 1725Bs, where on this graph, it's on the left-hand side of the dotted line for each of these graphs is the rebuild performance. The left whole graph is the read and the bandwidth, and the right whole graph is the write bandwidth. And we still see like 350 meg per second rebuild write bandwidth, which was the same thing we saw with the Samsung 1725Bs. And so something else that we tried was having a read going on the NVMe drive, but specifying a single write every n interval seconds or microseconds. And so here we varied the amount of time between writes from 1 microsecond all the way up to 2 seconds. And we see that the light green line on the left graph, which represents write for every 250 microseconds, is about the same bandwidth that we saw for the rebuild writes on the PM1725Bs and the Kioxia drives. And so to go a step further, we, instead of doing 1 write every n time, we said, hey, let's write a certain amount of data, like 2 gigs or 8 gigs per n time. And when we saw that, and when we tried that, we saw that the write bandwidths were actually raised a lot to about, the peak there in the light red graph is like over 2 gigs a second. So what we thought to do for the hackathon is to try to emulate that functionality in ZFS instead of just kind of writing rebuild writes kind of haphazardly, so to speak. We said, let's group a bunch of them up together, that amount being adjustable by a certain parameter, and then issuing that to the device. And to kind of explain what we did there, I'll hand it over to Brian if he's there.
Yeah, so what Trevor and I experimented with today is basically, Trevor's actually put a lot of work into this prior to today. He took the time to split up the VDEV rebuild queue. Originally in ZFS, the reads and the writes, they were being placed in the same queue. And so what he took the time to do in previous work was actually split those two things apart. And so today, since we had the separated queues, we basically identify, okay, if this is a write, let's just go ahead and first identify, have we met this maximum amount before we actually issue all these writes out at once? And so with this quick hacky thing we did today, we just added a module parameter. And if we haven't met a certain threshold of counts for the writes, we're not going to issue it out. We're just going to leave it there pending. And then eventually, once we hit that write count, we're going to flush them all out at once. And the idea is we're going to try and get to about 2 gigs. Right now, we're just doing actual counts of the IOs themselves. And unfortunately, we didn't get this all working today. In fact, I just got it to compile now. But our goal is to see if we can actually do the thing that Trevor showed in his graph, where we can get, instead of being bogged down for the rebuild writes down at 350, can we just group a lot of these things together, issue them all at once, and then kind of come to that center of the NVMe device for these rebuild writes? Because at present, with the Samsungs and, you know, even with the Kioxias, we're to a point where it's like we're almost stuck and better off doing RAID Z resilvers just to get the full write bandwidth of a single NVMe. So hopefully by tomorrow, we'll have this tested out and see if we match the results we were seeing. And we can, I don't know, maybe open a pull request, start a discussion about it. Although this version is extremely hacky at the moment, but we just want to see if we can get it to work. But that's pretty much where we stopped.
So I was working on triaging PRs and also putting together the videos from yesterday. So Brian and Mark helped me with this. We went through the oldest PRs and we got through one page, the last page of PRs we got through looking at all of them, and we found some that probably just need to be closed. We added a few to this spreadsheet of almost done ones that like need, you know, a little bit more reviews, and contacted folks on that. And that's about it. And then I also worked on the video for from yesterday, remembering how to use iMovie and what my workflow was from last year. I'll show you. So, you know, if I can't see it very well, but you know, throughout the other, you know, this is my the first talk, the one that I did yesterday. Manoj is next up. Tell us about long ops.
Yeah, so if you looked at the command line options for ZDB, you would notice that it has a ton of options, 37 to be precise. I went and checked this morning. And if you want to add a new option, which I've been trying to do a little while back, it's a pain because all of the intuitive options are taken and you would like to have long options. And so that's what I did, added long options to ZDB so that you can do stuff like this, -- dump debug message, or -- Uber block. So you have all of these options, and at this point, all of them have short options as well, but going forward, if needed, we could add some long option that doesn't have a corresponding short option if needed. I updated the man page as well, and that's what I did.
Cool. Any questions for Manoj? I think that's a very useful, a little bit mechanical thing that'll make our lives easier.
Yeah, I think the main function in ZDB could use some organizing, but I'm very glad to have long ops at least as a starting point.
Cool. Thanks, Manoj. Next up, we have Tony and John.
That sounds good. Give me 1 second here. Let me share my screen. So what we did today was working on adding ZVol performance tests. I'm sure that everyone is aware that we actually don't have any ZVol performance testing, and I didn't think about it until I saw there's block MQ change that went in, and I kind of realized that it's a gap for us. And I kind of brainstormed with John, and we thought that it should be pretty straightforward for us to add the support, right? Because the performance suite already have a lot of the common code and infrastructure. We just need to modify a lot of the FIO sort of parameters and how we kind of build up the ZVols instead of data sets. And so so that's that's kind of what we spent time today kind of experimenting. So you saw the command I just ran. I just kicked it off, basically given a couple of disks to the test, and the test, what we got working is the sequential writes and sequential reads to ZVols. Let me see. So you can see that, things are happening, and this thing should only take about 2 minutes. So I think we'll be able to get to the end of it pretty quickly. Maybe. Yeah, so I think the idea is that we were able to prove out that we can get this done pretty easily for writes and reads, and we can go through the rest of the other tests, right? The random read, random writes, and then the cache reads and such. Hopefully we'll be able to kind of wrap this up and then have a PR out so that we can have ZVol performance coverage. I can show you what the sort of the results look like. I'll take it from the last run. Oops. Get it from the current run as well. So you can see that basically sequential reads, with 128K, 1 meg, and sequential writes, with 1 meg and 8K IOs. That's it. Anything else, John, you want to mention?
Nope, I think you've covered it all.
Cool. Thanks. That'll be a great addition to the ZFS test suite. Any questions for Tony and John? All right, it looks like next up is Alan.
So I worked on an idea that came up, I think it was at EuroBSDCon, to have the ability to set something like the AltRoute property you can have on a pool, but on a data set that would just impact all of the child data sets. So I don't know if we want to come up with a different name for the property so it doesn't get confused with the pool AltRoute. But for now, I just created a property called AltRoute, and you set it on a data set, and it's inherited by all that data set's children, and that AltRoute gets prepended to the mount point property before when it's generated. So it actually takes the pool-wide AltRoute, then the dataset AltRoute, and then the dataset mount point, and concatenates those together to make the mount point. And the main idea behind this is if you're ZFS receiving datasets from another machine that might have the mount point hard set to something like /var, you want to make sure that all those datasets under your backup dataset or whatever are not over mounting the rest of your system or otherwise interfering with it, but you don't want to not set the properties because you expect those to be able to work and be able to chroot into that or whatever other mechanism you might want. I'm still puzzling a bit about how the inheritance should work. It seems to just straight normal inheritance seems to do what I want at this point, but it'll be interesting to see what other people think and what use cases there might be.
Cool. Thanks, Alan. Questions for Alan? All right. Then we're coming to the last person that has signed up, James. And so if anybody else is thinking about doing a presentation, now would be a good time to add your name onto the list.
Okay. Can you hear me?
Yep, I can hear you fine.
Thank you. Today, I will describe this as wasting your time efficiently. I'd just like to thank Alan for his extreme patience for my many questions. I've done programming a bit, but nothing on ZFS. So this was kind of a leap into deep waters. So I figured in my foolishness, I would take the simplest thing to start with. So I looked at the PR 11711, introduced VDEV properties, and figured I'd try to add something simple like add a few test cases. And of course, Alan was very helpful in pointing me to similar tests for other properties. So I took a look at that, and then I reread the PR that he had done, and I looked at his examples in the description of the PR just to see how it should work from the command line. So I manually tried the commands, and they worked. So then I looked at the code to see what all the other properties would be gettable and settable. And then I tested each one. And of course, on the third thing that I tested, I had some great excitement. And by excitement, I wish I did not have that excitement. If you set the path to something random, just as a test, it accepts it. And if you reboot and the path is something random, your pool will not load. And then I had the excitement of mentioning this to Alan, and he suggested hey, boot from the ISO file and try to mount it from there, which after 2 attempts, it did not ever successfully mount on the first attempt. It did load, and then the path was auto-corrected. At this point, I could boot back into my regular FreeBSD VM, and it worked again. So he identified where in the code it was checking for, it was only looking for a prefix of /dev. So to confirm that that was not a serious problem making the pool unbootable, I tried to set the product to the path to /dev/ASDF instead of just ASDF. And then the pool did automatically boot, and it corrected itself to the correct partition drive and partition ID. So that was cool. So after I manually tested all the other parameters, I didn't find anything else that was incorrect. So that was good. And at that point, I asked if the man pages also needed to be updated. And of course, Alan said, oh, yes, go ahead and do that. That sounds like it should be easy. In the back of my mind, I'm thinking, not knowing that I would have some excitement of mandoc being a new format I hadn't looked at. So of course, it's like Chinese. I mean, I've done HTML, so I know annoying prefixes and suffixes and all that nonsense, but it was a fun thing to edit, let me just say, and fun by not fun. So I added a very rough update for the man pages. I'm sure it will need to be tweaked, and I've checked that in and forwarded the link to that to Alan. And I made a list of all the manual things I did for the testing the properties, and I think I'll just separate like the list of properties into the ones that are read only, and just make a test of can I read it and can I not write it. And then for the remaining properties that are writable, I'll just make a write modify test. And in a perfect world, I'll have that done tomorrow, and realistically, maybe sometime this week. And that's it. If you want to jump into a project like this from zero, it's a very steep learning curve, but I would have to say extreme thanks to Alan for his patience. So thank you very much.
Cool. Thank you, James. That's
Yes,
great.
thanks for working on that and getting the man page started.
Yeah, I know it's not easy to get started. So thanks for sticking with us, and thanks, Alan, for helping him with that. All right, I posted the URL in the chat. You should be able to click on that and then choose from two categories, the best quality hack and the best hack in the open class. The prizes are going to be puzzles, as I mentioned earlier today. So puzzles, these wooden puzzles with cool cutout shapes with a theme of different insects and bugs and cool nature stuff. And we'll have two prizes or two winning entries from the quality category and one from the open class. And we need a few more votes because right now we have a tie. A few more votes in the for the quality things. Okay, now we're not tied.
I can vote again.
All right. So let's see. Now, I guess maybe what I'll do is I'll share my other screen and you can all see the results. Please don't modify the results, I guess, after oh, people are still, oh no, there's another tie. Oh my goodness. All right, so we gotta get one more vote. Somebody vote for the best, there's a tie for the quality hack for second place. Uh-oh. All right, well, I'll disqualify the one that I did. That's how we'll decide. All right, here's the results. So for best quality hack and winner of the hackathon, automatically rerunning failing tests, Paul, congratulations.
Thank you.
And tying for second, pool VDEV properties, James and Alan, and triaging old PRs. I will disqualify the team led by myself and give second place to pool VDEV properties, tests, and man pages. So congratulations, James and Alan. For the best open class hack, block reference table. Congrats, Powell and Alan. In a close second, very close second, trailing by just one vote, was long options for ZDB. So almost congratulations to you, Manoj. Sorry. All right. Cool. Thanks, everyone. I'll leave the Zoom here open if folks want to socialize or continue the discussions on their hacking. We'll have, we'll do this again next year, hopefully in person, and hopefully in person and online combo. Next year will be really fun. And we'll send out a survey to folks with kind of questions about, what you think we could do better, that you can do better at the conference, that you can submit anonymously, that hopefully we'll put together the next day or two. I think that's it. That's all that I have for the conference. Thanks everyone for participating.
Well, thanks, Matt, and everyone on your team for helping put this together.
Yeah, happy to do it.
That's good. Bye, guys. It was fun. Thanks.
It was. Thanks, everyone.